Good morning, kids. I don't know if you watched the video that I had posted earlier in the classroom, but apparently there's no volume. So we've troubleshooted that for the past half an hour, and now we have volume. So here we go. D of r of x, so this guy is a composite function. Okay, so we need to look for my inside function, which is r of x. So I'm going to take my r of x, which is square root of x minus 1, and plug it in for x, which is then squared. So d of r of x is going to be my function. I'm going to write it first because there's an x right there, the square root of x minus 1, and then being squared. Now because the index is 2 and my exponent is 2, these two guys can cancel out, and I'm left with just x minus 1 for my answer. If this is the part that's confusing, because I think that might be it, I want you to think of it like this. The square root of 3 being squared. Well, what does this exponent of 2 mean? It means that there's two of them. So root 3 and root 3. And then if I did some math, I'd get root 9. And what's the square root of 9? Well, it's 3. Okay, so if my index matches my exponent, those two buddies can just cancel out. Number 7 was the other one that you guys had some questions on, so I'll pull that up right here. And I have h composite r of 17, and here's my two functions. My issue with this is I don't like it. So I'm always going to rewrite it, if it were me, like this, because then I can focus on what's inside. So 17 is inside my r function, so I'm going to come right here. I'm going to say, fine, r of 17 is equal to 17 minus 1, which is the square root of 16, which is 4. So now my r of 4 is the output to my r of 17. So I'm going to take this r of 17, I'm going to move it, and I'm going to put in the 4. So now h of 4, in right here, square root of 4 is equal to 2. And here we are. Hopefully that worked.